Hi everyone, welcome to this video where we're going to be going through the first section on exponential and logarithmic function. Here is the syllabus. Review the inverse relationship between exponentials and logarithms. We're going to talk about that. This second one here we're going to leave to another video about really defining what the natural logarithm function is. And the third one here is use the change of base formula to convert logarithms from one base to another. We're going to leave that for another time as well. So really we're going to just focus on some basic logarithm laws, the relationship, and some basic laws that you need to know about logarithms. We all know about exponents, and we've done these rules here probably back from year 8 or year 9. So we understand these rules. What I want to do today is just define what a logarithm is and talk about some basic laws. So exponential functions and logarithmic functions, we should know what they look like. So let's have a look at the graphs of, in this case here, 2 to the power of x and logarithm base 2 to the power of x. If you look at these two functions here, you'll see that 2 to the power of x is going through 1 on the y-axis, and logarithm base 2x is going through 1 on the y-axis. So we know that these two functions are inverses of each other. That is, one of them is a reflection in the line y equals x. So if I actually add that line in here, y equals x, you can see how one of them is a reflection of the other one in that line y equals x. Now, if I change the base, you can see what happens to the graphs. So if I stop it around about there, this is logarithm base 10 of x in the blue, and the red one we've got y equals 10 to the power of x. So it's still going through 1, and you can see that each one of those is the inverse of the other graph. Okay, so logarithm graphs, you can look at all different kinds and have a look here what the effect of changing the base is, 2 to the power of x as opposed to 5 to the power of x. We just saw that in the graph, as opposed to 1.2 to the power of x where it gets shallower. If you go to 0.2 to the power of x or 0.5 to the power of x, you get these graphs here over on the left hand side. So that's kind of flipped around in the y-axis. Okay, logarithms, really useful things, guys, really useful. All our logarithm tables is the way people used to do large calculations, and I'm not going to go into the history of that now, but it was a Scotsman, John Napier, that discovered logarithms. So we've already seen the relationship between a logarithm and an exponential function, and that they're inverses of each other. So there's some basic ideas here on the on this handout about that you can skim through about the graph. So what are logarithms? Logarithms are just numbers with different bases. So here's this little demonstration. We've got the normal number line along the top here. Let's say that this is the base 2 number line. So I'm going to write all these numbers here with a base of 2. So 2 to the power of 0 would be 1. 2 to the power of 1 would be 2. 2 to the power of 2 would be 4. 2 cubed is 8. And 2 to the power of 4 is 16. What you see here is a logarithmic scale that we're developing. So these are just the basic numbers written with a base of 2. If I do that again for the next line down and say this is the base 3 number line, 3 to the power of 0 is 1 right there. 3 to the power of 1 is right there. 3 squared, which is the same as 9, is there. And 3 cubed is 27, is off the charts here. So if I know that this number line has all the numbers with base 3, I'm just going to get rid of those bases, and there's our logarithmic scale. They are logarithms, 0, 1, 2 there. If we had a base 10 number line here, then once again 10 to the power of 0 would equal 1, 10 to the power of 1 would equal 10, and 2 would be off at 100, wouldn't it, on this number line here. So you're seeing these logarithmic scales going on. So that's really what a logarithm is. It's just a number written to a different base. So we need to understand here the exchange between a logarithmic statement and an exponential statement. So log base 2 64 equals x is the same as 2 to the x equals 64. So we can then evaluate things like what is log base 2 64. by saying that's equal to x and then finding out. So in this case, x is equal to 6. You can see that in the example of finding the value of log base 5, 125. This is going to be really helpful if we're in the non-calculator section. Have a look at these two examples also, log base 25 of 5 and log base 5 of 1 over 25. Just using those basic definition of what a logarithm is to convert to an exponential statement and then solve those equations. Down the bottom here you saw that on all of our graphs that log, doesn't matter what base we are, log of 1 was always 0. So on the graph, if we draw a logarithm graph like this, log of 1 is always 0. And if we say log base 2 of 2, that's always equal to 1. That's another little fact that you should know about logarithms. So, first two questions is that I want you to answer here is the answers to example 5. What is log base 264 and what is log base 418? Can you write the answers for those two? Okay, logarithm rules. We've got 3 rules down the bottom here that you need to be really familiar with. I know we've already covered these. Log xy is log x plus log y, log x over y, log x minus log y, and the last one, log x to the m, is m log x. I'm not going to derive these rules. They're 3 rules that you need to be really familiar with and be able to use really well. So let me do this first example here. Log base x, so it doesn't matter here about what the base is the same, and that's important. The base has got to be the same. So if I do this question here, that's going to give me, let's just zoom in, log a plus log b is log a times b. Okay, so we've got log 24 minus log 6, and we know log a minus log b is equal to log a over b. So 24 over 6, which is log of 4. Now it doesn't matter what base we're dealing with here, the answer would be the same. It would be log to whatever base that is of 4. This one's a little bit harder. 3 log 2 minus log 12 plus 2 log 4. So I'm going to write this as log 2 cubed minus log 12 plus log 4 squared. Okay, so that's using that third rule there, where the number down the front then becomes the power. So we've got log 8 minus log 12 plus log 16. So using those laws, that is log 8 over 12 plus log 16. And using the first law, log a plus log b is log a times b. So we get 8 over 12 times 16. And if you wanted to, we could tidy that up. 8 over 12 times 16, which would give us log 32 over 3 after a bit of simplifying. Okay, last two questions for this video is I want you to do these two examples on this page, simplify and evaluate. So I actually want to give you a number for that one. And the last one where you have to actually use the fact that we've got a base 6 there to solve that equation. So use some log laws first and solve that equation. That's it for this first video, and you should have 4 answers in here in answer to the questions.